Now, please join me in welcoming our keynote speaker, Professor Ibizab Abdul Qadir, Associate Professor in Informatics Engineering, Faculty of Engineering, UIR Indonesia. He is also a visiting professor, research scholar, School of Engineering and Applied Sciences at Harvard University. Please welcome him.
Thank you, Prof. Basim. Good afternoon, everyone. Can you hear me, Prof?
Yes, we can.
Okay, all right. Good afternoon in Korea and good morning, early morning in Boston. First of all, I would like to say thank you very much again for the Smartcyber 2021 to invite me as one of the speakers in these sessions. For the community chair, all the faculty members, KDO presidents, deans, let me say the screen. Okay. So just sharing the work we have, what we are going, what we are doing now. This information. Sorry, maybe I not speaking loud because I am at home now. Not to disturb others. Okay, all right. I try my best in this session. So what we are doing now is actually this project is Indonesia, our government fund to identify the contaminant source location of river water. We try to monitor by real-time monitorings. So as mentioned, I am from University Islam Riau, UIR, Indonesia. Actually, I have been here in KDU last year. So I see Prof. FC as well, Prof. Noor, Prof. Besem, Prof. Grace, and Series. So now I'm in Boston. I'm visiting research scholar in Harvard University School of Engineering and Applied Science. So let me go. The idea is this one of the common river in tropical area. So the land something like flat over here. So it's unlike like river in like Korea and Japan and other country. There are maybe like a terrain, mountain. So in tropical and especially in Indonesia, the river is common use for the community, for the transportation, the activities, even their for washing. They use river water for the daily life and the farmer, everything. So very potential to get polluted. The idea is why actually is the several equipments to detect water pollution is in common. But the equipment when we install, they are good data. If the pollutant is high, they just give the data is high. They don't have not much intelligent system. If we buy equipment in the market and commercial, yes, we can install, we can get the data, but the data is something like this. We got experience from the government that they install one set of the systems. So they just install, if the river is good, the water quality is good, yes, they got to keep the lower a good result. But sometimes even like was or like garbage passing to the, they just give data also high. Actually, just small garbage or trash passing on the river, so they get high data. So this is not accurate data. They are say sensing send the river is polluted. So what we are trying to do something like some our river is got industrial waste through the river. So what we are doing to do is actually this The one of the case study is in our region is in Sumatra, especially the Riau province. The river is passing in the city. Actually, the river is common use for every transportation industrials, even the local transportation. They say river transportation for the community. So the river very busy because they're passing through cutting the city. So what we do is something. The river is like this. Let me right inside the population of the community is very high over there. So we try to deploy some sensing to the river. This some the river is something like this. But they are common transportation every day. Even it's not only a small vessel, even the shipping containers passing through the rivers. Currently, the method to check the river pollution is something like manuals. The government authority, they take samples from the river. If there something report from the community, so they take sample going to the lab, they analyze. Sometimes they take 2-3 days to get the results, and the result get when the result get polluted, so something like too late to get action because the result already even 1 week. So if the river is detected polluted, so 2-3 days, even 1 week already late to get action. So now we trying to do is like real-time monitoring. We try to deploy sensing system, communicate to database to backend system, like common parameter. We try to detect temperature, dissolved oxygen, salinity, the flow rate of the water river, then the level as well. In this system, we try to develop as monitor area in the city. So we try to deploy some nodes. This theoretical how many coverage area by that. Actually, the river is quite long. More than 200 kilometers, but we try to monitor on the city, just on the city that they are part of the river that busy. So we try to use sensing clusters for the wireless sensor networks. Let's say we try to monitor this area, so we can calculate how much percentage area we can cover to monitors. Let's say we deploy some nodes over here, sensing, so we can estimate how many percent the river or the accuracy of our monitoring system. We tried, we developed from the scratch, because why? In the commercial, we can buy the equipment, but we limited, we cannot access more detail because when the company sell the product, so we have to deal with them, so because of the data and others design. We try to design our set, and this communication system is the block is a sensing system, and this is a communication system. So why we try to design from the scratch is most commercial sensor have limited access of data. Then when we buy, we have to deal with them, all the data going to them, or we have signed agreements, contract, something like that. And if we design by our own system, we can design and we can develop for the future as well as the cost. Of course, the commercial maybe for the quantity got the cost as well. So in initial testing, we have done initial testing in the lab. This calibration process. What we do is because we are designed from the zero, so we need to calibrate every sensor. Let's say for the temperature sensor, we try to heat up the water and check the reading. Make sure the reading is this processing to store data. And let's say the temperature sensor, this we use thermometer or to calibrate this the temperature, make sure the reading is the same. So this sensor is working as well, working accurate as actual temperature. So we try to heat up and cool down, make sure the reading is accurate as actual temperature. As well as for the other parameter like PS and other parameters, we calibrate and make sure the reading is accurate as actual condition. After that, we have done calibration in our lab like this. Then we try to farm data to database, and then we deploy these deployments. We try to deploy in actual site on the river. So we try to put a solar panel because the river is remote areas. There is no utilities or electricity. So we try to put solar panel. So they are daytime. They got a storage battery. So they are this sending data. They use because in the city we just use GPRS modems to send data to the backend system. So our system keep log the data every day. So we get monitored data. So in the database we had some data to do to analyze. So they based on this the area just now the river. Currently we try to put just 6 sensing 6 node in this area. There is coordinate N1 node 1 2 3 4 5 6. So every node contribute data, or every day send the data, monitoring data to our system. So we try analyze data by data, sending by system. There is a challenge as well, because sometimes because of disrupt some not send data, sometimes it interrupt. We need to maybe a few hours they don't send data. So what we do is we try to store in the local systems. Then by every hours they send data to the system. It's not we collect data for 5 minutes. 5 seconds. Every 5 seconds they store one data. Every second from data. Then after 1 hour they send back to the system, instead of we send every 5 seconds. Because busy traffic, we keep in our internal system. There is a memory. Then after 1 hour, by modern system, GPRS send to backends. This data we try to use something simple algorithm to analyze the data, and data training as usual in computer science. We try to optimize to find the exact location. We use some theory from others paper. One of the paper study to try to locate the contaminants, but they are working on the something like it's not flowing water. Just one sensor. We try to develop the idea or to put based on several sensors, several not on the flow water. So we get contaminated. This theoretical when the water is flowing. So the speed of water flow is very reflect to the contaminant not. Of course, when the raining season, the level higher, of course the water flow is very fast, and the dry season, the summer, maybe less water. Then so this very affected to the location of the contaminant. So we try to use this theoretical analysis to find. Now we use 6 nodes, so got x1 to x6 to yes, this one. So the delta, we can get the amount of residuals in the nodes by calculate these comparisons, because each other node contribute data very related. Yeah, related. So we try to analyze by this algorithm, because when not one detected some contaminants, the water flow into the node 2, node 3. So the speeds, the N1, node 1 may not contaminated because of the pollution, the chemical is passing through the node 2 and node 3. This depend on the flow. So based on this case, we have done so far, we conclude for the like 1 years, 10 month or 1 year last the data we have collected before. So this not 2 and not 4 very potential because the community over here, the transportation, so we can give the report to the authority. So this area have to be carefully checked because the industrial operation, the busy area, so we can give report to authority to check on the site how to prevent, how to clear up, or how to is at least we got something help to the government to authority to prevent their issue. So the next actually the research is still ongoing. The next we try to find what is actual cause the contamination. Is it from agriculture, sewer, oil pollution, or industrial? Because currently we just detected the node location. Instead, before, because the government, the environment agency, they put sensing. Every time sensing say they got polluted, in actually they are going to the site and spot check. There is nothing. Something like earlier, as mentioned earlier, there is a garbage or trash just pass to the river, so they are deleted. So we try to identify, because need times we need to analyze the data. It's not just a spike data or temporary data. So next, we try to identify what is the cause of the contaminant. Is come from industrial or agriculture or community or trust, and the actual chemicals content and the polluted water. Is it nitrate, mercury, based on this report is the case study. Several industrial operatings, and every industrial they use specific chemicals, so the government can check what kind of chemicals content in the polluted water, so they know who use these chemicals, come from where, so they can decide action to the pollution source. So this next research is still ongoing, and currently, for your information, currently I am in the Harvard. So actually, US and in Indonesia, and especially the South Asia, also get similar issue like fire. There's a hot spot in US, like California. We had discussed always every day in summers in the California, a lot of forest fire. So we try to identify currently just hotspot. They are get the data from the satellites or ground sensing, just spot the hot spot. They don't specify is the spot potential for fire. Even sometimes the community fire the garbage or fire the trash at the house. This consider hotspots. This we try to classify what type of hotspot is potential to get a forest fire. So far, we have data about 500,000. We're trying to get more data, more than 1 million data fires. These coordinates, latitude, the coordinate and longitude of the fire. Some fire is not, it is confidence level is low, sometimes low. sometimes it's only 40 and even below than 30. Is if the more than 80 is confidence level is highest potential to get forest fire because the fire spot come from fire. The low confidence levels maybe small fires like as I said just now is just community just fire their government is not potential to get fire. So we try to do as well consider other parameters. Currently they are just when the hotspots identified, they just identified. Next, we try to focus and do analysis based on wind's direction, wind speeds. Sometimes, like our state, is there is no fire because wind blow to our this our is central Sumatra, because the fire from the south of Sumatra, because the wind blow to the north, so identify from ours. We try to analyze based on other parameters like direction of winds, speed of the wind, even the temperatures. So far, we have data from 2013 up to try to 20. So this data we try to analyze. Maybe got more data, more than 1 million data. We try other parameters like wind, temperature, January, February, when what is the maximum temperature, the lowest temperatures, how this situation over there. So we try to analyze based on many parameters, so we get accurate result and forecasting. So there's what we are doing in Harvard now, together with the US researcher as well, to find how to forecast the fire in US and Asia as well. That's all my presentation. Thank you very much for your attention. Thank you.
So, thank you, Professor Elizal Abdul Kader. It was really impressive as usual. The research area is one of the unique research areas that we are aware of, and frankly, not have much knowledge in this area. But frankly, we'd like to see if there is some questions from any members in the attendance in the Zoom or in YouTube, or even here in my colleagues in the conference room.
Yeah, I think, hello.
Yes, yes, Prof. Mangal.
Hi, Professor Abidal. I think it was really one of the finest presentation. And I think this kind of work is very helpful country like, especially in developing country like India, Indonesia, and Sri Lanka, Bangladesh, and all those countries where water pollution is really one of the biggest concern. And you have pointed out many interesting points. I have just one question. If you can go to page number 25.
Yes.
On page number 25, actually, you mentioned like you can figure out on which point. You can go a little bit more down.
Yes.
Yeah, this one. So you can identify the pollution location. So let's suppose it's location number N2. So
yes.
But after that, if you will also identifying, then all the next location will be also polluted, isn't it? Or do you have put some threshold, like we have pollution, some particular parameter for N2, and when we are measuring at an N3 or N4, it will be a little bit different than N2, because we have, like, let's say water is 10% polluted, and at N3, if it's about more than 10% or 15%. So did you put some threshold on that one? So how you identify that it's not the same pollution level at N2 or N3 and N4 on the next one? I mean, I'm a little bit curious because the water is flowing on the same river. So that's what I'm a little bit curious.
Yes, correct. Yes, every node send the data, contribute the data is different. We have set a threshold depend on our set. Maybe just now, maybe 10% of polluted, 20, 30. So we trying to identify not to is all days is indicate got contaminated. So we conclude is this polluted waters. So N1 and other N3 and 6 is only sometimes. As okay, as I early presentation just now, maybe the chemical is just passing on the river, so it is not considered as polluted.
Okay.
Before that, sensing system just send the data. They got alert, triggered something. So we have data to analyze. We collect data. It's not. I think even not only 1 day, 1 week, even a month is not enough data. We have to data trainings, how the behavior of the rivers. In the morning session, maybe community use the river water, so all the throw the garbage, something like that. Then after that, 1 to 2 hours finish. So it's not considered is polluted because just temporarily. So we try to train data as much as possible. So we consider this not to is because we spot check also industrial operation over here. So they are the sum of their waste from industrial production going to the rivers. Something like that, Professor.
Yeah. Thank you so much.
All right.
All right. So, any other questions from YouTube? Okay, I have a bit question, same thing in terms of when it comes to the water detection and monitoring the quality and detecting pollution, it's very critical and very not easy environment. So, could you elaborate how, in terms of the sensors range configuration for that?
Yes, well, we trying to collaborate with the chemicals peoples because we just detect basics. Actually, basic parameter already get a clue because we temperature, conductivity, because dissolved oxygen in the water is there is oxygen. If the low oxygen, sometimes fish die or something like that. There is contaminated from chemical. Actually, we have discussed with chemical people. Based on this parameter, we already get the what kind of chemical content in the water is just common. If we go into the specific chemicals like radium, selenium, we have to put other sensor. So we try to analyze based on all parameter like 4, 5, 6 parameter. We try to analyze if the temperature hikes, dissolved oxygen hikes, and like acid hike. So we can work with the chemicals, what the actual chemical content in the waters. So this currently based on the basic 4 or 5 sensing, we already get the chemical content, but it's just basic chemical based on the waste from communities, industrial. If furthermore, we have to install a specific sensing related to the what kind of let's say we already identify mercury on our river. So just something like maybe 50 or 70% accurate. To get 100% or 90 accurate, we have to put something like mercury sensing to probe that accurate result. Something like that, Professor.
Right. So that's really interesting. In fact, any other questions? Anything to say? No questions.
So I have one question about the real time, because your work is real time monitoring. So You mentioned that there is no electricity there in the river, and also the sensors has to collect data and send it to your server for the analysis. So do you think that will be real? I mean, the implementation will be real time, or it will take some delay?
Yes, Prof. Actually, it is real time. As mentioned just now, there's some interrupts because of communications. Actually, we get real time monitorings. So the sensor, because the component is very low powers, we have tries when the battery is fully, this can up to 3 or 4 days power up the component. So when the sensor is sensing, so they send directly to a backend system use GPRS system. Previously, because the sensing is get data every 5 seconds, get one data. Every 5 seconds we send to backend system. This very because we had 6 node, something like traffic issue. Sometimes this additional interference or other. So what we change the designs. We keep the data on the internal system. We have memory over here. After 1 hours, then maybe a few hundred data sent back to the backend system instead of the every 5 seconds. So to avoid the communication issue. So it's considered real time, but maybe every hours. Every hour we analyze data, every hours data. Because why the report also is not real time. Even every day is still considered is still okay. I mean every hour is still okay. I mean we can do every 5 seconds or every 5 minutes. 1 hour is still acceptable to report to the government that is communicated is instead of the every 5 minutes or 5 seconds. So the real time we can do real time as well.
Okay.
Like there's a profession, yeah.
Okay, so that's very interesting. Thank you very much, Professor Rizal. It's
Yes.
always a pleasure to follow up with your research and new work environment. So you might tell us more about Harvard and how it's going on there.
Yes, thank you, bro. Yeah, Miss KDU, as I mentioned last year, I was with you all. So hopefully I can do better in the Harvard because they have got more facilities over here, and hopefully the research is more beneficial for our community and for all of us. Thank you, Frog. Thank you for your invitations. Again, thank you. Yeah.
All right. So in fact, we have another speaker, Professor Anna from Australia.